A problem with adding more and more lights to a scene is the expense. Every light you add means yet another light that must be evaluated for the surface. One way around this is deferred rendering. Look at this demo. There are 50 lights in the scene and it runs just fine. Normally you render a surface and the fragment color for each pixel is stored, if it's the closest visible object. This is often called forward rendering. In a deferred rendering algorithm, you instead store data of some sort at each pixel. There are many variations with names such as deferred shading versus deferred lighting, and here's just one. You could store the position, normal, and material color and shininess of the closest surface at each pixel. You also draw into the Z-buffer as usual. I'm not going to get into the details of how you store these various pieces of data. The point is that you can do so. It's just image data in another format. With deferred rendering, every point light in the scene has an upper limit as to how far its light goes. This distance forms a sphere, so a sphere is drawn in a special way for each light. Another way of saying this is that each light can affect a volume in space. Whatever surfaces we find inside the sphere are affected by the light. Each light affects a fairly small number of pixels on the screen, namely whatever area the light's sphere covers. This means that a huge number of lights with a limited radius can be evaluated in this way. By drawing a sphere, we're telling the GPU which pixels on the screen are covered by the light and so should be evaluated. There are variants on what shapes you draw: a circle, a screen-aligned rectangle. Whatever is drawn, the idea is that the geometry's purpose is to test only the limited set of pixels potentially in range of the light. This is as opposed to standard lights, where every light is evaluated for every surface at every pixel. I hope this gives you a flavor of how deferred rendering works. I'm really jumping the gun here. You need to know about shader programming to implement these. But the idea is to treat lights as objects that are rendered into the scene after all object surface values are recorded. There are some problem cases for deferred rendering techniques, such as transparency, but it offers a way to have an incredible number of lights in a scene.